Okay, this is just a quick video to talk you through what's happening with Lab 6, the Superposition Lab that I'm aiming to finish off on Saturday. Right, so the LT spice that I've put up here on the screen, hopefully you can see it now. This piece here, this is the full circuit. This piece here is what happens when we neglect the current source. We replace the current source with its ideal, which is an open circuit. That means there's no current flowing through R3, so we can remove R3, so we're just left with R1, R2 and the voltage source. Then the second circuit down here is what happens when we remove, or at least replace, V1 with its ideal, which is just a short circuit. Right? And then we can do a couple of things. One of the big problems with this lab is that we don't have a power supply that gives us constant current. Right, so we have to figure out what voltage we need to apply to give us 5 milliamps. And we can sort of do that here, right? So here's the voltage that we need for the main circuit, right? And it's about 2.03 volts. But then we've got the same thing here, right? The voltage that, and this one is node 7, and node 7 is this one here, right? So for this one, we need about 3.9 volts. Now, I did that calculation during class last week, right? So here's the circuit. Effectively, the 1200 ohm and the 270 ohm are in parallel. And then that equivalent resistance is in series with the 560 ohm. So the overall equivalent resistance is about 780 ohms. And from that 780 ohms, we can just multiply it by 5 milliamps in order to get that the appropriate voltage, which is 3.902 according to my calculations. 3.902 volts. Okay, that's pretty much it. I'm hoping I'll have lots of questions about it on first thing on Saturday. Let's try and get the lab wrapped up, and I also wouldn't mind trying to do one of the other labs, and we might spend the day doing labs rather than me talking to you. Labs and tutorials. I have a couple of tutorials that I'd like to get started on as well. Okay,